Okay, so in this lesson, we're going to look at conversion graphs. You've already done quite a few conversions for me, but none of those questions required any graphs. All you had to do was lots of multiplying and dividing. All the questions from now on will require a graph one way or the other. Furthermore, I wanted to point out that all of the questions you've done so far were only one particular context, and that context was switching between different currencies. Now, that is probably the most common situation when we need to do conversions in maths. But the second most common is when you need to switch between different units. So if you take something simple, like look at your ruler, you will see that you can measure lengths either in centimeters or in inches. And sometimes you might need to switch from one measurement to the other. If I said that something was 5 centimeters long, you might need to convert that into inches. It's about 2 inches, by the way. Now, the graph you can see on the screen is a conversion graph between litres and gallons. Litres and gallons are measurements. What they do is they measure what we call liquid capacity. So if you go into the supermarket and you see like the orange juice in the cartons, typically they're sold in litres, but other things are sold in gallons. I'll show you, if you've not seen a gallon before, let me help you to visualize it. So let's think of milk. When you go into the supermarket, you might see milk that looks like this. The little one on the left is a 1 pint, often milk sold in pints, isn't it? That pint is also a measure of liquid capacity. So the one on the left is a pint, the one in the middle is 2 pints, and the one on the end is 4 pints. In America, they tend to sell milk by the gallon. So in this picture, on the left of that picture is a 1 gallon carton. It's massive. The one in the middle is they call it a half gallon, but that's the same as 4 pints. So the one in the middle there for the American milk is the same as the blue one on the right over there. And the last picture on the American milk there, they call it a quart, and that's a quarter of a gallon, but that's the same as 2 pints. That's the same as the green one in the middle over there. So there's different measurements for milk, and then so that big red one, that's the gallon measurement. Litres look more like this. So if you look for the ultra heat treated milk, so the milk that lasts for ages, that normally comes in 1 litre cartons. And if you ever buy Yeo Valley, that for some reason they don't sell in pints or 2 pints, they do their own thing and they sell in litres. So the Yeo Valley ones come in litres. So that's a gallon and that's a litre, just to help you visualize how big they are. But anyway, this graph will help us switch between one measurement and another. Just like I said earlier that 5 centimeters is 2 inches, we can switch between litres and gallons. And we can, of course, use the same method you used earlier with the currency. You can just do lots of timesing and dividing, and you will do that. But the graph actually helps as well. Now, it turns out that this was actually the top half of an exam question, and the bottom half of the exam question looked like this. And I'd like to take you through how you do each question just one stage at a time. So the first one, use the graph to change 50 litres to gallons. Notice how it's instructing us to use the graph. So even if there are other methods available, which there's lots of ways of doing this question, the easiest way of doing the question is say, hey Siri, what's 50 litres in gallons? And in everyday life, that's a perfectly good way of doing it. But this question is insisting that we use the graph to change 50 litres to gallons. So here's how you would do that. Here's the graph again. 50 litres, well, the 50 litres is on the y-axis, isn't it? All the litres are over on the y-axis. So the 50 litres, you find the 50, and then you draw a line across from 50, but you stop that horizontal line when it hits the graph. And then you turn the corner and you go down because on the bottom, on the x-axis, is the gallons. And so you need to read, where does this vertical line hit the x-axis? And that will be our answer in gallons. So 50 litres looks like it's hitting the x-axis at 10.9, maybe something like that, because each of those little squares is 0.2. So it's a bit more than 10.8 and a bit less than 11. I think that's about 10.9. Let's go with 10.9. So the answer to the first question is 50 litres is the same as 10.9 gallons. It's not like I've got more or less liquid there. That's the same amount of liquid, but just two different units for measuring it. Okay, part B, use the graph to change 6 gallons into litres. Okay, very similar idea, but this time I find the 6 gallons, and I'm not going to do the 6 that's over on the y-axis. It's the 6 that's on the bottom, because all the gallons are down there on the x-axis. So I find the 6 gallons, and then I draw a line up to the graph, stop when I hit the graph, turn left, head towards the y-axis, and that number there where I hit the y-axis is how many litres 6 gallons is worth. Now I think, now look at the 20 and the 30, and that slightly bolder line between the 20 and the 30 would have been 25. And I think this is halfway between 25 and 30. So when I read that, I get 27.5. You don't have to agree exactly. When you draw your lines, you might get 28, or you might get 27, or you might be slightly different. But that's expected, because when you're reading graphs, your line might not be perfectly horizontal or perfectly vertical. You try to be as accurate as you can. But when you're doing these graphs, you're expected to get within a certain accuracy. You're not expected to get the exact answer. That would be asking too much. When I read that, I get 27.5. I hope you agree. So 27.5 is my answer there. Now, part C is not insisting that we use the graph. It doesn't say use the graph to. So, before I go on, I should say that this is how we show that we're using the graph. I don't mean just look at the number 6 and look at the point where it touches and then look at the y-axis. I mean, actually physically draw these lines on there. These red lines that are in my workings, you have to draw those as well. And I'm going to recommend you draw them with pencil, but you actually physically write those lines onto your graph, and that is communicating to the person reading your work that you're using the graph and not doing some other method. Right, sorry, I digress. Now, part C doesn't insist that we use the graph. We can use whatever method we like. So I think we should use the same sort of method you use for the currencies. Now, the question tells us that 1 litre is worth 1 litre costs £1.15, but we want to know how much 50 litres would cost. Maybe that's the petrol tank of a car or something. It can fit 50 litres in. So I hope that's obvious to see that to get from 1 to 50, that's just been multiplied by 50. It's a direct proportion situation. So if you buy more litres of fuel, you would expect it to cost more money. As one number goes up, so does the other one. So times by 50 and times the other side by 50. I did that on my calculator earlier, and £1.15 multiplied by 50 gave me £57.50. I haven't done anything clever there. I've literally just typed it into the calculator. Part D, work out an estimate for the cost of 1 gallon of petrol. Now, I haven't got enough information here yet, because the question was only telling me earlier how much a litre costs. I don't know how much a gallon costs. So I probably ought to use the graph to switch the gallons into litres. So let's try that. When you look up 1 gallon, it's 4.6 litres, give or take. Maybe when you do it, you think that looks more like 4.5. Maybe you think it looks more like 4.7 or something like that. It's about 4.6. Okay, about 4.6. But I'm going to use that. That's good enough. The question did say estimate, and in fact, that's why it says estimate, is because it's very difficult to be exact when you're reading a graph. So let's say 1 gallon is 4.6. So I know then if I buy 4.6 litres of petrol, that's a gallon. That's the same as buying a gallon. So if I times this by 4.6, I get £5.29. 4.6 litres is 1 gallon. That's the same thing. So the answer to the question is £5.29. Now, did you notice there in part D, I had to do a bit of both. I did a bit of graph work and I did a bit of work, like in part C, like you did with the currencies earlier. So you're mixing all the skills together, and that's why it's a good exam question, because you're having to do lots of different skills all at once. Now, this was a very specific exam question, but there are other skills which you need to do which weren't on this particular question. So here's an example. In fact, there's two. Use the graph to change 80 gallons into litres. So the exam question didn't ask this, but I'm asking it. Use the graph to change 80 gallons to litres. So how do we do that? Let's have a look at the graph again. So if I go down to the 80 gallons, yeah. So, oh, I can't find 80 gallons. I'm looking at all the gallons along the bottom, but there's no 80. That's miles off to the right, and so we haven't got enough graph. That doesn't mean we can't do it, though. It just means we have to look up something else. Because we can't look up 80, we'll have to make do with just looking up something else. So how about that one that we used earlier? We said that 1 gallon was 4.6. So we could use that from the graph and then do a bit of multiplying to help us. So the graph tells us 1 gallon, 4.6 litres. To get from 1 gallon to 80 gallons, I hope it's clear that that's just times by 80. So I get my calculator, do the same to the other side. And if you do, type in 4.6 times 80, it tells you 368. 368. So I tried to use the graph to look up 80 gallons, but it wasn't on there. And I chose to do this one, didn't I? The one, and that comes out as 4.6 litres. But that wasn't my only option. I could have chosen all sorts of things. I mean, a lot of people would have chosen something like this. The question wanted 80 gallons, but if you look up just 8 gallons, it's quite easy to use this answer. Now, when I look up 8, I think that hits the y-axis about 36.5. You know, you might get slightly differently. You might think, oh, why? I think that's actually 37, or I think it's 36.4, and, you know, you might read it slightly differently. But I think when you go from 8 up to the line, I reckon that's about 36.5. So we could use this one instead. If 8 gallons is 36.5, to get from 8 to 80, it's just times 10. I chose 8 because it's easy to get from 8 to 80. There was no point in looking up 7. So go back here. I said you could use that. You could use that. There wouldn't be any point in looking up something like 7 gallons because it's hard to get from 7 to 80. But to get from 8 to 80, that's easy. Just times by 10. I don't even need a calculator for that. 36.5 times 10 is 365. But hang on a minute. When I did it earlier, I said it was 368. So which is it? Is it 368? Is it 365? Is it somewhere in between? Is it the average? It doesn't matter. Okay, it's only an estimate. We don't have to be perfect with the graph. We just have to read as close as we can. And as long as it's clear to the person who's looking at your work that you've used the graph in order to do this question, then you're going to score marks. 365 is fine, 368 is fine, but you have to have used the graph. And remember, this is how you show it, isn't it? You draw these kinds of horizontal and vertical lines on there. That's how you show that you've used the graph. And as long as those workings are on there, I don't think it matters whether you do the 365 answer or the 368. I think either is fine as long as you use the graph. Now, this last bit is a little bit tricky. So really try and pay close attention to this, although it's not the most important thing in the world. All the previous stuff is super important, and you have to definitely fully understand that. But this next bit is a little bit tricky, and it pushes it a little bit to higher level skills. Just do your best. So find the equation of the graph. Find the equation of the graph. Well, find the equation means we want some kind of link between the x and the y coordinates. I want to know how the x and the y coordinates link together. What's the rule from one to the other? Now, we actually did quite a lot of work on the equations of straight lines earlier in the year. And we said the general equation was y equals mx plus c. M is the gradient, c is the y-intercept. Don't worry if you've forgotten most of that right now. We'll revise it later on. But that is something that we've done already. The good news for you is that with these conversion graphs, it's a little bit easier than all of that y equals mx plus c stuff. The rule that we're looking for is simply that I have to multiply x by something to get the y. So let's have a little look. Down here in red, I've done, what if I just multiply by 1? What if I don't really do anything? So I plotted the points 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. I've just plotted those points there where the y coordinate and the x coordinate are the same, but clearly that's not the same line. My red line here is not steep enough. That's not correct. So it's not just do nothing. They're not the same number. Nor is it double. It's not the case that the litres are just 2 lots of the gallons. That's definitely not true. So I've basically plotted the points here at 1, 2, 2, 4, 3, 6, 4, 8, and so on, and join them up with a line. But that's not right either. That's not steep enough. Same idea. What if I did y equals 3x? What if my rule was you times the x coordinate by 3 to get the y coordinate? That's not steep enough either. How about 4? Nope, that's no use either. How about 5? Oh, that's a bit too steep. Probably obvious then that 6 is completely pointless. That's even steeper. So I've established then that my rule is definitely something along the lines of y equals number times x. That's definitely right. Y equals number times x. But what number is it? Well, it's none of these. They all were wildly wrong. It must be a number that's somewhere between 4 and 5. Okay, somewhere between 4 and 5 to get the correct equation for this line, the correct rule that links the 2 coordinates. Okay, you can have a guess if you like. It turns out the correct rule is 4.6. And I'm hopeful that you're thinking, oh, I've seen 4.6 before. Yes, it's not a coincidence, folks. 4.6 was what you got when you looked up 1 earlier on. When you looked up 1 gallon, it was 4.6 litres. That's not a coincidence. In fact, that's how you work it out. Your answers will always be y equals some number times x. And that some number is just what you get when you look up 1 from the x-axis. Let's summarize that then. So the rule was y equals 4.6x. And it's always the case that for a direct proportion situation, remember direct is where as one number goes up, so does the other one. If it's a direct proportion situation, then the equation is just y equals some number times x. I've called it k. Y equals k times x. And you can figure out what that k is if you just start on the x-axis at 1, and then when you hit the line, head left. So for our particular graph, it gave us 4.6, but for other graphs, it will of course be different numbers. It's always start at 1 though. Okay, if you want to know what that k value is, what am I multiplying x by to get y, you always start with 1 on the x-axis, and then you can look up what it is on the y-axis. Last thing, there's one more question on the sheet that you're going to do, which is like an extra bit at the end, but I'm sure many of you will want to know how to do it. So here's an example coming up of how you would deal with questions like that last one. I'm going to introduce cat food to help us understand it. So here's a massive box of cat food. I want you to imagine this is just an enormous, like the biggest one the supermarket sells. This is an enormous box of cat food. How long will that last for? It's enormous, after all. Now, there's various factors that will help us decide how long this will last for. Probably, though, the most important thing was, well, how many cats have you got? How many cats are going to be eating this food? If you've only got a couple of cats, it might last quite a long time. If you've got 50 cats at home, it probably doesn't last very long at all. So I hope it makes sense to you that the number one thing that helps us to answer that question, how long will this last, is just how many cats have you got? And in fact, this graph answers that question. For that big old box of food, I've got the number of cats that you own along the bottom on the x-axis and how long the supply will last in days up on the y-axis. So let's look up some numbers just out of curiosity, see what happens. So what if you had 4 cats? So the graph is telling us if you've got 4 cats, the food will last for 9 days. So it's easy to use the graph in the same kind of way. So even though this is not a nice straight line, it's still easy to use the graph. So 4 cats, it would last for 9 days. What if you had more cats? What if you had 12 cats? Now the graph is telling us that it would only last 3 days. And I think that does actually make sense because to get from 4 cats to 12 cats, well, that's 3 times as many cats. And if you've got 3 times as many cats eating the food, it'll only last 1/3 of the time that it did before. So this is an inverse proportion situation. As one number goes up, the other number goes down. So if you've got more cats, the food doesn't last as long. The more cats there are, the fewer days it lasts. I think that makes sense, but it is a harder situation to try to wrap your head around. There is one more little twist here. When it's an inverse proportion situation, something stays the same, but something is different about the equation. So if I want to find the equation of this graph, it's no longer y equals a number times by x. It's no longer k times x. It's y equals a number divided by x instead, which again is probably not that surprising, because as one number gets bigger, the other gets smaller, and that happens with division, doesn't it? If you divide by a bigger number, you get a lower answer. So it's much like before. It's still looking up the number 1, but it's now k divided by x instead. We've got a slight problem though. If I try looking up from 1 on the x-axis, it misses the graph completely. Can you see that? So I'm trying to look up 1, but it doesn't miss. It does actually hit the graph eventually, but it's off the edge of the screen. It's much higher up. So I can't easily tell when this line hits the graph, but no problems. 1 on the x-axis is 1 cat, isn't it? So I just need to work out how long would it last if I had 1 cat. That would be my value of k. So for inverse proportion, it's k divided by x. I need to look up 1, but I can't. So let's use something we knew from before. We knew that 4 cats, if you've got 4 cats, it lasts 9 days. But I want to know, what if I only had 1 cat? Well, 1 cat is a quarter of the amount of cats. So surely it will last longer. It will last 4 times longer. It will last for 36 days. 9 times 4 is 36. So if it lasts 36 days for 1 cat, my k is 36, and I have that the equation of this graph is y equals 36 divided by x. And that's the answer to the question, by the way. Where does this vertical line eventually hit the graph? It would hit it up at 36, which is higher than 20, so it's off the edge of the screen, but it does hit the graph eventually. It doesn't just miss forever. Now, there's one more thing we need to think about before you can start doing these, and that is if you have a printer or not. If you do have a printer, then you've got sort of no problems at all, because when you're doing questions that look like this, you can just print the sheet and start writing on it. That's not a problem. However, if you don't have a printer, then you need to start by copying this out. And it is really important that you copy it carefully. I appreciate that this might take you a while. I appreciate that it's a bit tedious. If we were in school, I'd be photocopying it and giving it to you. But we're not, and we have to make do. So you will need to copy these if you don't have a printer, because you can't do the questions on a graph if you haven't got the graph in front of you. So a tip for you. We can decide on the scale, but if we decide that that is 1 centimetre, then that whole length there will be 13 centimetres. And if we decide that that is 1 centimetre, then that is 11 centimetres. You can just literally count them, how long that is, and you get that it's 13 times 1 along the bottom and 11 times 1 up the side. So when you copy it, you'll need to make sure that you use the same. And this point is also really important as well. If you didn't see it, it's up there in the top right. Red dot is appearing, flashing at the moment. Okay, that point is really, really important. It's the point 1255. And you can't put that diagonal line in a different place. If you don't plot the point 1255, you're going to have the wrong graph, and then everything goes wrong. So I'm going to stop sharing my screen, and it will look at the little graph that's in the bottom corner now, hopefully. I'm hopeful that you can now see this handwritten graph. And I want you to notice that I've done exactly what I said at the end of that video. I've measured carefully 13 centimetres along the side. I've measured carefully 11 centimetres up this side. Okay, can you see that? 11 centimeters. Something else that's really important is when I was doing this, I was using a sharp pencil. Sharp is important, so it's accurate. If you've got a really blunt pencil, then it's hard to read accurately because you end up sort of blurring between 2 or 3 different little squares, and it's hard to read accurately. So sharp pencil is important, but also it's very easy to make little mistakes, and so pencil definitely. Don't try doing this in pen, please. These things are important. These little markings down here, these are called tick marks, and you do need to do them. It is important that you put them on there. What it's telling, the reason for that is the number 1 is exactly that point there on the scale. The number 2 is exactly that point there on the scale. If I didn't have these markings, it's hard to see what do I mean by 1, exactly what do I mean by 2. Another common mistake that I sometimes see is people accidentally labeling the space between the lines rather than labeling the lines. This is a scale, it's not a bar chart, so we're labeling the line, we're not labeling the space between the lines. That's really, really important if you're going to copy it accurately. I also said that the point 1255 is important, so we'll plot that on here accurately as well. So start at 12 and go up slowly and carefully. Here's my 50 across here, so 2 squares higher is my 55. And then take your time with this, do it carefully and accurately, because that point is super important. If this point is wrong at the top, then the whole graph is wrong. So there we go, there's my point 1255. You can see 1255, 2 squares higher than 50. Right, best of luck.